And yes, we are going to record this symposium. Okay, maybe Arimura-san, I am going to show my slide. Okay. Is this a presenter mode or a editor mode? 荒木さん、どっち見えてる？
Symposium on DV Chikyu borehole observatory cruise.
これでいい。
Good.
Okay, okay, thank you very much. And okay, before Araki-san is going to explain the project, Chikyu Observatory project, let me explain about JAMSTEC cruise category. As I showed in this slide, in JAMSTEC, we have, let's say, three type of cruise category. The first one is the cruise category we are going to discuss. I call it JAMSTEC cruise. This cruise is carried out to achieve JAMSTEC midterm research plan. And we JAMSTEC science team have to request the budget to next every year. And to do that, it is very important to say about the social relevance of this project. And also, it should be necessary to open the science community for this project for participation in any stage of project. And also, we should organize a workshop to hear the community's interest about this cruise. And so this is our first category. And second category is external funding cruise. For example, the cruise which is carried out by the JSpace funding or the funding from other ministry like a METI or non-Japanese funding like NSF and so on. And the combination of the category 1 and 2 also can be considered to carry it out. And the third one is IODP Chikyu cruise. And for doing this cruise, necessary expenses are covered by income of Chikyu by the commercial project. So we have those three categories about JAMSTEC cruise, and we are going to discuss about first category cruise, Chikyu cruise, which plan to do next year. Oh, something is missing. Okay, I have some figure in the right top, but this Chikyu cruise is proposed to achieve JAMSTEC midterm research plan, and in the Institute of Marine Geodynamics, JAMSTEC, in this midterm, we are doing research work to understand the sleepy behavior of subduction megathrust and its temporal evolution. So for doing that, we are doing monitoring and imaging and modeling subduction zone. And Chikyu cruise we are going to discuss is a very key part of the monitoring approach to understand the sleep behavior of subduction zone. Okay, and for monitoring, the very important approach we are doing is constructing a seafloor real-time continuous geodetic network using DoNet cable system as infrastructure to transmit the data from sea to land in real time. And we have been installing borehole or seafloor geodetic observatory by seafloor drilling machine, BMS, on research vessel Kaimei, and also drilling vessel Chikyu. And yes, the Alexander System Development Group, they also developing and testing a fiber optic sensor to connect the DONET system. And as you know, under the IODP Nantroseas project, they successfully deployed 3 borehole observatory of Kumano region. I think this is white dot location. And those stations provide us very important data to monitor the slip behavior of shallow part of subduction zone. And we monthly reported data from those stations to Japanese headquarters of earthquake research promotion. And in the next year, I mean this year, next fiscal year, starting from this April, we are going to deploy another borehole station, probably around this area to connect to Net 2. So Alex-san is going to explain this observatory cruise by Chikyu, this workshop. And as I mentioned before, this workshop is held to hear the community interest about this cruise. So those who are interested in this project to join in any stage of project, please give us your thought and your comment during workshop, or you can send us comment or your thought through a Google form, which we will mention later. And for the very future plan, so we plan to deploy our borehole station in here, and we continue to request the budget to next to deploy our additional 2 station, which hopefully will be connected to NNet system. The NNet is a new cable system, and NID is working very hard to deploy this system. And JAMSTEC is very much cooperate with them to establish this NNet system. So this is very much future plan. So, okay, as I mentioned before, this workshop is very important opportunity to hear the science community about this project. And I'd like to hear the comment or your interest from those who are interested in this project. Okay. So this is today's agenda. We are going to have the presentation from Alex-san, and we are going to have some general discussion afterwards. Okay. Alex-san, can you start your presentation?
Yes. So thank you for joining.
Yeah, okay.
Thank you for joining the symposium. I talk about the borehole observation for real-time slow slip event detection in the Nankai Trough. So today I talk about the concept of the project and IODP borehole observation and detection of slow slip events. And we are running also the related project to the new borehole observatory installation, which is seafloor fiber spectrometer and fiber optic sensing, and also the in situ pressure calibration technique. I talk about them, and then I explain about our status of new borehole observatory design and development. And then we also consider the candidate site for the drilling. And then I talk about the tentative or current plan of cruise schedule and then the connection to DoNet to get data. So the background, as a background, throw trip event and the throw earthquake occurs around the epicenter of the large earthquake in Nankai Trough, as you know. And the Japan government watches these throw trip occurrence to understand normal states during the interseismic period. But the shallow part of the subduction, the coverage is only by intermittent GNSS-A and borehole array observation in Kumano area established by IODP program. So, but the IODP borehole observatory array of Kumano region is very important to monitor such a transient occurrence in the offshore part of the subduction. And most of these events identified by the offshore borehole observatories, we are not able to even notice by the land-based thermometer geodetic observation. So seafloor borehole observatory has great sensitivity to capture shallow throw trip events in the Nankai Trough. And the question is how sensitive this seafloor borehole observatory could be. So this is the model calculation from the past observation by the seafloor borehole about the small patches of throw events. How small seafloor change would be expected for these events. For example, seafloor uplift and subsidence for the dislocation of 1 centimeter of 10 kilometer fault cause only a few millimeter change in the seafloor, which is very difficult to detect by the seafloor pressure gauge. And chill is also small, less than 0.5 microradian at most, and the strain also 0.1 microstrain or smaller. So these small throw transients can be captured by the seafloor borehole because a stable and sensitive instrument in quiet environment can be established in the borehole. So this is why to expand that our sensitivity to the whole Nankai subduction zone, we requested the fund to build 3 more seafloor borehole observatory and linked to the DoNet to cover most of the occurrence in the offshore part of the Nankai Trough. And at the same time, we are working to expand our sensitivity for such a throw event by building various types of instruments in the seafloor. I talk about them briefly. One activity to monitor throw event is the deployment of tiltmeter in the shallow borehole, like 6 to 90 meters from seafloor, which was started from 2019. We installed the first tiltmeter in here, 1BS1 site, and we started the observation and by linking to DoNet one. And the throw slip event was detected in 2020 December to January and clearly. And the second activity is development on the installation of seafloor fiber optic telemeter. And we deployed the first telemeter in here, 2FS2 seafloor. And here I talk about this a little bit more detail that we captured the throw slip event, which occurred in January 2022 to February. And the third one is we also develop a technique to calibrate the working pressure gauges in the seafloor, and which has a better accuracy than 1 hectopascal, which is 1 centimeter seawater level change. So and we are performing a repeated calibration of seafloor pressure gauges in these sites to monitor long-term seafloor deformation, which I will show that later. And the fourth point of our activity is development of optical fiber sensing using a Muroto cable here, which expands 120 kilometers from shore to the very close to the end of the subduction front. And we in the development of optical fiber sensing, we developed a very broadband distributed acoustic sensing technology and TWCOTDR technology. And we perform continuous observation since 2021. So first, I talk about the observation of flow slip event and VLP by seafloor fiber optic telemeter. Seafloor fiber optic telemeter is measuring the length of the sensing fiber in comparison to the reference of the same length. And the connection data is connected to the DONET to be able to, so that we can record length change over time in real time. And this is the figure of instrument, which is housed in the titanium cylinder. And this is a sensing cable of 200 meters long in the spool. We use a ROV to lay the cable here to make like this. And we started the observation since 2019. And this is the location of the telemeter, which is located very close to the swarm of VLP events in the history. And in 2022 January, we recorded the throw strain transient that effectively changed its in extension about 0.7 microstrain over 3 weeks of time. And at the same time, almost at the same time, we also observed the swarm of VLP occurrence in a local location. If we look close up of each VLP event like this is 1 minute scale, and we noticed a very clear seismic wave from each VLP event. And if we make a 0.1 Hz low pass filtering on the record of strain meter, we also notice we do observe shift of transient of each strain for each VLP event, only for the local VLP event. And the sign of change of strain for each event has a variety, but have a systematic relationship with the hypocenter mechanism of each VLP event and the location the location of each event in relative to the location of the strain meter. So this indicates observed strain transient directly relate with the fault motion, which is occurring about 10 kilometers below the seafloor. And then going back to the long-term record of the trend transient, the sum of each trend change by the swarm of VLF events didn't account for the observed through transient of 0.7 microstrand, which we observed in 3 weeks of time. So the transient represent a slower forward motion, which is a shallow slope slip event, which occurred seaward part of the parameter, which is in the area of VFE swarm. So by being encouraged by this finding, we added 2 more parameters in November last year in the same location, like here, in different orientation for each parameter. And the new installation of the parameter, we buried the cable about 30 centimeters below the sea floor to improve the performance of the parameter record. So we expect this March component parameter array would give us more control on the mechanism of shallow slope slip event when it occurs in the next time. In these areas, we know that every 5 or so years, we have a slope slip event. And safer pressure calibration, we developed a mobile pressure calibrator, which is shown like here. Carried by the ROV, we can obtain calibration data of working seafloor pressure gauge. And if we repeat that process several times like here, we can obtain the instrumental drift rate of the seafloor pressure gauge to subtract from the original data to give the true seafloor pressure trend in the seafloor. In this example, near the perimeter site, the 2C10, we obtained about 1.9 hectopascal per year subsidence from the pressure data. And the other site has also recorded slightly smaller speed of subsidence by the pressure, seafloor pressure. So I think the mobile pressure calibration technique may also be used with a new borehole observatory to obtain true long-term formation pressure, which is very close relationship with the condition of drainage of the formation for fluid pressure. I will answer your question later. Thank you. And then I need to speed up. And I talk about also distributed acoustic sensing with Muroto cable. We started continuous dust observation in Muroto cable in 2021. Like here, in this example, we can record the very high spatial density record of each seismic signal. And now our observation range is extended to the almost end of the fiber, which is now about 100 kilometer range from the shore, is observed by the instrument. And during our observation, low frequency tremor occurred in this area. After our observation of VNF swarm in this area also has a slow earthquake occurrence. So we try to analyze the record and located VLFE as low frequency tremor events more better in more higher accuracy. And this result is corresponding to the local cluster structure. So this is the work by Baba-san. Then, so we prepare for the analysis of through aspects by the fiber record. And another development we are doing is to use the optical fiber sensing for the geodesy purpose. That has difficulty in long period monitoring of strain for the geodesy because it is somehow difficult to make stable measurement over very long periods, like years, not like 100 seconds or 100 like a year. And also the difficulty is dynamic strain change, like during earthquakes, result in a failures in optical phase tracking in dust. So we developed another type of the optical instrument called the TWCO-TDR, which is a tunable wavelength coherent optical time domain reflectometer, which is free from these two difficulties. So optical Rayleigh scatter wave is used in the optical fiber sensing, but we use in TWCO-TDR, the intensity pattern in frequency is shifting due to strain change, which is free from failure in phase tracking during earthquakes. And also, to make the stable measurement over years, we calibrate the laser wavelength of such a Rayleigh intensity pattern evaluation by gas absorption line standard. So the reference, our measurement reference is stable over years. And the developed TWCO-TDR instrument can sample fiber strain at 20 centimeter resolution, which is very high compared to the dust. So we are thinking about utilizing this optical sensing technology for the new borehole observatory. And finally, we got funding to prepare a steeper borehole observatory in 2021, and we started the development of a new borehole observation system for the new project to install the observatory here. Then I talk about our borehole observation system, which is being developed right now. And we are trying to monitor strain and porphyry pressure at about 500 meter depth from the seafloor. And these instruments are connected to DONET for real-time continuous borehole seafloor observation. So each observation component, like porphyry pressure, we will have two pressure ports at the bottom of the hole. Another at seafloor. So total of 3 component measurements by using a parascientific pressure gauge at cork head in the seafloor. For strain measurement, we are thinking about using a strain measurement for monitoring throw slip event, VLFE, and micro earthquakes, and large earthquakes also. So we are performing a very broadband, very high dynamic range measurement of the strain in the borehole. So for this purpose, we do not have the space of 200 meters in the borehole, so we developed the volumetric fiber optic strain meter, was newly developed. And in this strain meter, we want 200-meter long fiber in 150 millimeter diameter stainless tube about to form a like 2-meter long sensing surface, which it will be cemented like in this picture at the bottom hole. And we have the redundant component of the strain sensing, two components, which has a different thermal characteristics, which will be able to serve redundancy at the same time, compensation of effect of temporal temperature variation, which could occur like a milli-Kelvin level change over time. So then also, we are trying to minimize the electronical component in the hole, which could eventually lead to the failure from our like 10-year experience with the IODP borehole. So we place only optical components for the strain meter in the borehole. And we are planning to measure the strain meter by seafloor instrument. And the data will be connected to the DUNET. And we also have another fiber for optical fiber sensing, which is still being development stage. And we have the separate same length optical fiber wound in the mandrel here. And as I explained, we have the very high density fiber sensing technology, like 20 centimeter spatial resolution on the fiber. So that we can apply this technique over this press, which can enable us the directional strain sensing. And we are not we still don't have the instruments that can be connected to DUNET, but we can connect the instruments through the ROV from the shipboard instrument. So using that shipboard instrument, we can measure the fiber at the bottom of the hole. And we are planning to do that in drilling Chikyu and subsequent ROV visit by the when we make a maintenance of the instruments. So I think the subsequent ROV visit will measure fiber strain evolution with time in great detail, spatial resolution. And here I place the mechanical layout of the developed fiber optic borehole strain meter. Here is the sensing surface about 2 meter long, and the optical component is housed at upper stage, which will be connected to the tubing to connect to the up hole. And the optical circuit diagram, as I told, we have a redundant component of 2 fiber strain meter in the same interval. And also we have an optical fiber sensing component, which will be like a snake going back and forth to measure this 200-meter section wound redundantly. All of these fiber will be linked to the seafloor by 500-meter long fiber optic cable bonding. And to confirm our ability to this conductor installation, we performed several tests to date. First, we performed the optical fiber thermal characterization experiment in the temperature constant chamber, and this is the temperature going up and down, and we monitor the fiber strain due to the thermal change. And another test is a vibration test of borehole fiber optic strain meter frame. And because we expect to experience vibration during the lowering sensor string to the circular borehole by the Kuroshio current or uh, uh, C current. Vibration test performed in this very big facility confirmed our durability of the streamometer in expected vibration environment. Although this is not so strong instrument, we make this light and somehow weak to deform as the formation deform. But it is durable to the vibration environment. And we are also planning to deploy the same design borehole fiber optic streamometer in land borehole, which is conducted in March this year. So maybe 1 or 2 weeks later, we installed our streamometer in this borehole. And for the pressure, fluid pressure gauge, we measure the drift rate characteristic and the hysteresis of each pressure gauges for the borehole observatory to confirm that each pressure gauge has a high quality reading from the borehole. And this is the our planning of the well completion from Tomo-san, and we drilled about 500 meter, and the bottom 50 meter or so is for the empty place for the pressure monitoring. Then the up for location will be cemented about 300 meter maximum, and we have the cement. We cement the streamometer in the borehole, and we have the two cables. One is for the fiber optics terminated in the cork head here, and the another is the hydraulic tube. We use flat pack to the uphold. Also terminated here, and we have pressure gauges on the cork head, which will be replaceable also. And we consider the site to install our borehole observatory. We currently think about the two candidate area. One is close to the DoNet 2F node, and the other is DoNet node 2G. And we currently think that 2F site is primary because of non because of the balance of areas to monitor. And here is the condition of the spot we drill the hole. One is for the purpose of the throw slip event monitoring, we need to place the proximity to known or expected throw slip event. And also the one important point to limit our location is low risk in drilling. Because to reduce the cost and the time for the drilling, we do not install casing, which is used for the previous IODP expedition. And so that we also try to penetrate deeper, but the installation of lower consolidated sediment layer is one safe but possible way to record terrain in good shape. And the third point is important point is DoNet connectivity. So in our case, about a 2 kilometer or shorter length of the cable to link to the DNet, which limits our possibility very much, but we try our best to find the spot. And of course, we do have many submarine cables, not only the DNet and the commercial, and so many places. So we need to avoid these cables. So after referring to the series of seismic sections shown here, which we also needed to get the seismic reflection data after consideration of the 2F node 2F location. So here's the seismic lines we referred, and after the consideration, we locate the candidate site along this seismic line. We call the ZN2F1 for the tentative, which has a water depth of 2620 meters water depth. And the depth from this is the DNet to backbone cable, which is about 1 kilometer away from the DNet 2. And the coordinate is shown here. And the location here is close to the existed DNet station MRF-223. And in this map, I didn't show, but the fiber optic stream meter in the seafloor is located here. We also have the MRF 24, 25, and MRF 22 DNet stations, which give us a broadband record of the VFE, and the pressure recording is also available. So with the borehole installation, we can have a very dense coverage of the observation in the proximity of the through trip event expected to occur in here. This is the overlay of the past observation of VLIP and plate topography from Nakamura-san. So our candidate site here is situated around some change in the basement depth, and also close to the edge of VLFE, non-VLFE occurrence. And the observation from here, the last through trip event occurred in last year, has an extension trend change here. So somewhere here will be the candidate through trip surface of the last through trip event. So we will observe the trend through trip just above the fault plane. And this is a seismic cross section and in the shallow part of the candidate site. This is this is a cross section along the MRF-23 DNet station. We have the sediment basin right here, and we also consider the candidate position here, just with that about 500 meter penetration, we reached to almost to the prism sediment. And but the cable distance to the cable is very short in this site. And here, candidate site DN2F1 is about 1 kilometer away from the cable location, which we will confirm that by the visual inspection later. But here, with the 500 meter penetration, we still have in the deeper part of the sediment, but very close to the accretion of prism surface. And this is the east-west transect of the nearby location and in the northern part of the candidate site, which has a shallower uh, uh, prism interface. And this is the velocity estimation, the Poisson ratio estimation using Tonegawa-san's seismic analysis and multi-channel seismic data. And here is the candidate site profile and at depth of 500 meters. Young's modulus is like this, and so this is a nearby location estimate. So somehow moderate or kind of average level of stiffness in the rigidity in the depth of the 500 meters with the new site. Poisson's ratio is not too soft, but not too hard. Yes. And the cable route to the new borehole is we plan like here. We have a node at the top of the trough bridge, and we need to climb down the mountain. And, up to that location, we expect a steep location. So we use the existing and working route to use, and then when we come to the bottom sediment basin, we head to the candidate site storage spot. So total length expected is about 15855 kilometers. And we confirm with the visual inspection by ROV in coming March or May cruises. So finally, I talk about the cruise schedule plan, which is starting from November 6th from Shimizu Port, coming back to Shimizu Port in November 30th. During the cruise, we drill the hole and installation of sensor, and we also perform initial borehole measurement, including powerful pressure, strain, and fiber sensing using a various optical technique like a TWC OTDR, Brilliant OTDR, and DTS, and possibly DAX included. And then we also plan to perform connection cruise using a SynSema and ROV hyperdolphin from December 28, 2023 from Yokosuka to stop by the Wakayama port in January 4th. And after January 5th, we have another leg to end January 14th in Wakayama. During the cruise, we are planning to connect the borehole observatory to ZooNet 2 node and also perform borehole fiber sensing to find out the change after the borehole installation. So I welcome your comments and questions and also the interest to join in this project. Please contact me or it's okay to use the Google Form. Thank you very much.
Okay, Araki-san, thank you very much for giving us an overview of the seafloor geodetic project and also detailed explanation about the Chikyu borehole observatory system and the cruise. Okay, so let's have a discussion section. The primary objective of this symposium is to discuss about borehole observatory cruise with the scientific community. And also, we'd like to hear your interest to join the any stage of the borehole observatory project. And also, as Alexa mentioned, we are going to we are doing a very variety of seafloor geodetic system development project. So if you have any question about the overview of the seafloor geodetic project, I'm very much appreciate to hear your comment and suggestion. Okay, so let's have the discussion section. Maybe it is not easy to discuss by Zoom, but if anybody has a question, comment, and a suggestion about Chikyu cruise, as well as the geodetic, seafloor geodetic project, please just raise your hand. Okay, Damian, please.
Good morning, good afternoon, everybody.
Good morning.
So one question or comment very quickly is for discussion, if it's okay, how do people feel about maybe going to a gallery view in Zoom so we can see each other? Is that okay? There's one idea.
Yeah, yes.
Just because Zoom is challenging. And then a quick question. So for the drilling measurements as the prior to the installation, it says initial borehole measurement. Will there be any logging while drilling to understand the condition of the hole and collect any information about the kind of borehole environment before the sensors are placed?
We do not have a plan to perform LWD simply because of the budget limitation. So our current goal is just to try to install borehole observatory with a minimal cost. Of course, the knowledge from the logging is significant, and I hope if it will be performed, but probably very, very difficult from the financial condition. And using the fibers installed in the borehole, we are trying to perform the kind of dust sensing or strength sensing, which would be able to give insight of the condition of the borehole. So which is still the kind of very initial development, but we will try. I think this is very challenging, but we also hoping to collaborate.
So the borehole completion will be done with kind of an idea of just from the drilling experience and the OSI's intuition, kind of.
That's right.
Okay.
The one data obtained during the drilling is of course the torque measurement, which is also important to identify the risk of collapsing a borehole. So again, this will be important intuition from the drilling operators. That's right. That's right.
Okay, thank you very much, Damian. Any other comment, question, suggestion? Looks like the Martin. Do you have any comment, question?
Yes, I'm here with Earl, actually.
Yeah.
Oh, yeah. Okay.
Good morning.
Greetings.
Good evening. Thank you very much for joining.
Well, it's congratulations on all of the technical advances. That's very impressive. Sensitivity really looks good, particularly with the fiber optic sensors. Two questions. One is, what is the estimate of porosity at 500 meters for the upcoming hole?
This would be very slow, like less than 1.8 kilometer per second, I think. So in the figure of the young modulus is about very small.
Right, right. I mean, that tells it all, I guess, is that estimate for Young's modulus, even more so than porosity. The other question is, are you going, what sort of grout are you using to try to match the formation as best as possible with respect to the modulus of the formation?
Yeah, thank you for your question. This is very important, and we estimated from the seismic velocity about the Young's modulus. This is to try to test our cement prior to the drilling to match the as much elastic characteristic to the formation. So this will be tested in May or somehow later. And we are also wondering if we also place the fiber in the test piece to make a measurement of the initial strength change within the cement.
To get a sense of what the grout curing does to the
right
to the strength. Yeah. Okay.
And also the final stiffness could be measured with the test piece.
Yeah. Okay.
Okay, thank you very much. I think Martin asked some question during Alexander's presentation.
I can answer Martin's question about the CFLA fiber parameter. We use the ROV towed trough to like a cake cutting. We cut the surface of the sediment by like 30 centimeter, and we press the fiber inside at the bottom of the cut surface to bury the cable. So we try our best to minimize disturbance to the sediment. But as far as we see from the seafloor picture, like here, yeah, some disturbances there. But yeah, observed data didn't have some transient which appeared frequently in the surface deployment of the fiber. So I think it is a very useful technique.
Yeah, it looks really impressive, and I guess like it probably takes like a while for everything to settle down. I guess like you just like installed it like a few months ago, right?
But the deployed stream meter fiber with the buried technique is very quickly somehow stable. Yeah. So maybe friction from the fiber to the sediment is very good.
Thank you.
Thank you very much.
Okay, thank you very much. See any other comment, suggestion? Oh yeah, Tian, please.
Araki-san, so in the borehole diagram for that cork, I saw that you put a pressure gauge at the bottom of the hole. So which is kind of different from the previous design of cork, where we typically put the pressure gauge at the wellhead and then with a hydraulic tube.
Yeah,
so
this is the same design, almost.
The same design, okay.
Yeah, we will have a mini screen at the bottom hole, and we have a pressure tube to connect mini screen to the cork head. Then we have a array of pressure gauges, which is using peroxide, and but the system development is performed by Japanese manufacturer, and we use as a peroxide to monitor these three pressure pods. One is looking at the seafloor.
Okay, Okay, I see. Okay, because I saw there are like two blue cubes down there in the hole. I saw those are indicating the pressure
Oh, and
sensors, just indicating the location where those tube will go to.
one correction to this diagram I noticed is currently we are planning to monitor the bottom part pressure redundantly, which is we use two in separate mini screen and hydraulic tube, both looking at the same zone. In this picture, this is shown to monitor cemented section, but this is not the case in our current design. So our intention is to get a redundant set of observations in the bottom hole, which is most valuable data we will expect from the borehole. But I'm very much welcome for your comment.
Thanks.
Okay, Kian, thank you very much. Any other comment, suggestion from the audience? Oh yeah, Damian, please.
I'll ask another question, but so above the cement in this diagram is open hole. Is that right?
Right.
So how hard would it be to include an additional pressure sensor in that zone? And I guess the reason I ask is that without any knowledge of the permeability architecture, we don't know what kind of formation we are in at the bottom of the hole. And so it may be kind of undesirable lithology for pressure sensing, whether it's because it's noisy or it's actually, some other issue, gassy or something like that. And so having a kind of redundancy in that respect might also be helpful, right? So you separate the pressure sensors, but that may mean a third one, which may be a cost issue. So I don't know.
Yeah, one point is we are preparing a flat pack, which has only two conduit. This is limiting us. And another point is we would need a 12 packer. Maybe not. So this is the most critical point of our decision. So one point is if we abandon the redundant set of the observation at the bottom, we can of course place the one hydraulic tube in the middle of the borehole above the cement. So which will be, of course,
understand. It's a kind of trade-off. Yeah.
Damian, thank you for the very important comment. Okay. Any other comment, suggestion, question? Yeah, I understand it's not easy to ask question and having a discussion through Zoom, but what about Japanese audience? Any question, comment, or interest for joining this project? Oh yeah, Karin, good morning.
Yeah, just a question for Araki-san.
Yeah, thank you.
Can you provide a bit detail about a stream meter?
Yep.
So what's the mechanism? What does it provide at the end? What kind of signal it yields?
So the fiber for this parameter is all found in the stainless tube and cemented, and measuring the length of the 200-meter fiber, which both all observe the area.
Yes,
area.
sorry for the top diagram. Are we looking at the which one is vertical? Which direction is vertical in this diagram? Vertical is vertical.
This is the borehole perimeter, so the up is here.
Okay, so this is we're looking at the borehole.
Right.
Like
Right.
horizontally. Okay.
No. So this is the diameter of about 200 millimeter. So this is kind of a mandrel surface with a fiber wound.
Yeah. So what? Just tell me what is the number 4630 at the bottom? What does that mean? 4630.
The total length in millimeter. I'm sorry. So this instrument has a 4.86 meter length in length.
Okay. So it's vertically placed in the. So what the string components does it provide?
So because the fiber is wound in the just 150 millimeter mandrel, and the length is measured. So namely this would respond to the area of the sensing mandrel.
Okay. So it does not provide components like max,
but
normal strain.
one point is that we also apply optical fiber sensing, which has very high dense sensing of the strain. So that we can identify this surface has a more strain, and the other side will be less strain. Kind of sensing is performed if we can apply the very high spatial density measurement. So in that sense, we can probably notice the uneven deformation of the sensing tube mandrel. So that would give us the directional strain component.
So can we derive a kind of like 2D strain tensor out of this?
Possibility. So although we are not confirmed that the potential yet, so we are trying to test it in our Kamioka installation online prior to installation. But this is the first trial, and we have many points of question, of course, as you have.
Yeah, thanks.
Oh, Karen, thank you very much. And Martin, do you have the question?
Yes, I guess we were just wondering if you have if your sensor size your strain sensor size is kind of 20 centimeters, and then you have only a 20 centimeter diameter, then that's probably it's going to be challenging to tease out the directionality, right? But well, and anyways, you have many sensors, maybe you can figure that out. I guess my question was, have you any plans to do like DAS or any of the other kind of fiber measurements to develop a setup that you could take subsea, so that you can have continuous measurements subsea, or are the lasers and the interrogators, they're just so big and the data is so much that we're just years away from putting that on the seafloor and having continuous measurements without taking an ROV there?
Yes, we already started to consider seafloor DAS or optical instrument installation. One difficulty is funding, and the other one is power needed by these optical instruments is very large at the moment. So we are trying to minimize the power demand of such an optical instrument, but probably we would need to limit 60 watt in total to allow new optical instruments connected to the borehole observatory. We are working at this moment, also trying to get funded. This is honestly at the current stage of development.
So what's the current typical power use that the instruments have in the moment?
So currently the DoNet has the ability to feed the power like 90 watts for the total system. And we lose some fraction of the power for the copper of the extension cable and also the supporting electronics in the interface. So the probably maximum allowable power for the system would be 60 watts.
Okay, and so I guess like like how much power does like a typical DAS acquisition system take up?
Commercial system normally has more than 200 watts.
Okay.
And of course the cooling mechanism is poor, so it will be stopping after some minutes.
Yes, and then I guess like you also need to have probably like a pretty powerful computer to do some subsea processing so that you don't have to send too much data home as well.
Yeah, so there are several treatments for such kind of difficulty. One is to minimize components in the seafloor to use up power. But in this sense, we do need a more higher bandwidth, which is not provided by the very old DoNet data transmission scheme. We need to provide something like 10 megabit per second data flow. In usually DAS or optical instrument, sample like 1 gigapoint per second. So this is very difficult to compress the data if we try to send it onshore by road. So maybe if we have a direct connection of the fiber to the shore, we can probably do the better job. So maybe the coming NNet or such kind of new network, we are trying to get more bandwidth by kind of direct optical communication to the shore.
Thank you very much.
Yeah. But I think the DoNet 1 and 2 availability is very important. And we are also trying to make the best use of all the seafloor cable network. New or old. Okay.
Okay. Karen, do you have any questions?
Yeah, I have another naive question. Maybe Earl is more qualified to ask this kind of question. I presume you have a pressure sensor at the bottom. I presume you want to prevent that sensor from communicating with the borehole above it, right? If you want to get true formation pressure from that sensor.
I don't get your question very well. Because
but you have a borehole with no casing.
No
right?
casing, right?
Yeah, and then if you put a sensor at the bottom, and so the sensor will sense the fluid pressure in the borehole. But what you want is a fluid pressure from the formation around it. And so in that case, you want to prevent this sensor from communicating with the water in the borehole above it. Right, so somehow the sensor needs to be isolated from the borehole.
Because our pressure gauge is still on the seafloor. And
also there's grout, right?
Right. So we
Oh, I see. Okay. Yeah, this grout. Okay.
For zone isolation, of course. Yeah, there
And
are
also you hope
also
the
concerns.
formation, the rocks will eventually collapse around your instrument, or just
Not
ground.
sure.
Just ground. Okay, maybe it was already answered by Earl's question.
Right. So the reason why we press like a 300-meter section of the ground is to minimize the risk to communicate downhole, uphole. But of course, also we also have some concern. Maybe the cable the space between the cable and the tubing maybe could be performed like a pathway for fluid communication. So we need additional consideration to minimize that kind of risk.
Or Martin, do you have any comment or question related to this one?
I guess I would comment on the grout. If it's 300 meters worth, that's going well up into the sort of formation where you probably begin to lose grout anyway, into the formation laterally. 300 meters, of course, it's a guess, but that's probably adequate to deal with Kellen's comment or question. It probably does provide vertical isolation. If it were, 30 meters, you'd worry about contamination, pressure contamination around the grout to the open section of borehole, but 300 meters should be pretty safe. I don't know if it's too far off topic to ask a question that you could probably guess that I would have, which is the off-roto transect, which is now, the distributed acoustic sensing system, that's leading right out to the old boreholes 808 and 1173, which are currently possibly still collecting data, and at the very, most would require, knock on wood, would require batteries to revitalize. That's been done in a mixed effort among those of us on this side of the Pacific and now Masa, who's not at JAMSTEC. Is there any possibility within JAMSTEC to include those holes and get those back into continuous monitoring mode, but with occasional ROV visits? I know that they're in deep water compared to a lot of the ROVs that you're using for the shallower installations, but is that in your planning?
We considered both ROV visit and the revitalizing that with the cable connection. The ROV visit we have at this moment a difficulty, but we don't have the ability to get deeper water than 4,500 meters. So these are all the but new important ODP borehole has a deeper than that. So we are almost there, but we are out of reach of current ability of our ROV fleet. This is the current situation, and also that limits our potential to connect this borehole to the DoNet or other super cable. And I think in the future we would be able to make the measurement again with the legacy hole by adding a kind of offline recorder, but the service by AUV visit was such kind of potential we are still taking. Connection to the cable in that kind of location is possible, but kind of difficult, both in financially and also the technically. if we limit the connection only by the fiber, that would be feasible. So we still think about many options, but at the moment, our limiting the biggest limiting factor is both finance and also the ability of RV fleet.
Okay, thank you very much.
Thank you very
Alex, can you show us a map showing the cable and ODP side?
The older ODP site is located
somewhere around
here.
there.
Here and here. So this is about 20 kilometers away from the Moroto cable. So, and we are really hoping that we can have a service of this borehole.
Okay. Yeah, okay. I think this is very much kind of suggestion and idea we should think for doing that in future project. Yes. Thank you very much.
Thank you very much.
Oh, yes, Karim, please.
Well, I don't want to monopolize the Zoom. If other people just just in case nobody else is speaking, if you're allowed to drift away from the technical design a bit and thinking ahead, there's a lot of activity, VLFE and slow slip and tremor, everything being observed here, and to understand how all these things are related with the earthquake cycle in the bigger system. I guess it's important to compare it with another place. The most, I think that there's a big contrast with Cascadia, right? We don't see a lot of much of these things, right? We have limited observations, but with the, well, Earl and Martin can correct me. I think I'm right here. With the limited observations we have, we don't seem to have this such a busy, shallow system of the megathrust, right? We have a lot of seismometers. We have other things. We just don't see as much. I have a hypothesis. I think it has to do with the stage of the earthquake cycle, how long you are after the previous earthquake. But that's a hypothesis. But I think these observations are very important to make it really to extract the most fundamental information about a bigger picture. It'll be nice to have more observations from say Cascadia, but yeah. So I think maybe there's a way for a future collaboration in some way.
Yeah, I also hope to drill Cascadia for the getting a best sensitivity for such a throw processes in a nearby seafloor. So at least this is great opportunity for us to find out these shallow processes in situ. And I'm wondering also in the some long future, maybe shorter future, to monitor the fluid pressure in the decollement or port system joined to the such a throw motion to understand the frictional condition causing such a throw process.
Carrie, thank you very much for the comment about importance of to have the big picture of the several subduction zone. But Damian, you looks like you have a comment or thought about this topic.
Yeah, maybe just quickly to follow on
Yeah,
Kellen's
yeah.
comment is, this is a really exciting effort, and I think is a perfect example of how having more instrumentation and very high resolution data show us things, they reveal things we can't see. SC4D in the US and hopefully with international partners is moving toward major deployment, probably in Chile, but also components in Cascadia and Alaska. And its timing is very good because between now and April or May, there will be discussions about kind of details of things like a design, what kind of instruments, where should they be placed, and what is the density that might be needed to solve certain kinds of questions. And so I definitely invite, and I'm serving on one of the committees where we're beginning to discuss this. So if this group has suggestions or ideas for priorities, those can be factored into that implementation plan for a kind of comparison site to Nankai that could be very interesting. So,
yeah, Damian and Karen, it's a very good point. I think to understand subduction zone, looking at the subduction zone process in different cycle of the earthquake, like by comparing Nankai, Chile, Cascadia, and so on. So I think this kind of research, making a research network in subduction zone, it's very, very important of the future direction. And in the Nankai or Japan side, Japanese side, today Alexan is going, Alexan focused on the monitoring our study, but at the same time, JAMSTEC or Japanese active source group doing for the seismic survey to map the very detailed map of the subduction interface. And based on the very preliminary result, we can see some correlation between the roughness of the plate and BLF or tremor activity. So I think, as I mentioned before, the kind of integrated study of the monitoring, imaging, and also probably modeling in very much different stage of our earthquake cycle is a very, very important approach to understand our earthquake process. So I'm very much agree to have the international network, research network, probably Second Pacific region. Yes. Yeah, thank you very much.
Thank you very much.
Okay, any other comment, question? Okay, as I mentioned before, one of the objective of this symposium is to hear the community's interest to join a part of or entire part of this project. So I'd like to just hear your impression from non-Japanese scientific community. Do you think are there any scientists or early career scientists or a student who might be interested in joining the Chikyu cruise or this project? Damian, do you have any kind of impression?
I think you would find some interest in the US community for students. Maybe, it's not a very big community of people working on borehole instruments. So maybe 3 or 4 students from places like Washington, Oregon, maybe from my group. So yeah, I think there will, particularly in the drilling in the first of the 3 cruises, there are other communities, again, University of Washington, Oregon in particular, in the US, where there may be strong interest in the seafloor fiber cruises. So yeah, I think so.
Yeah, thank you very much. So if you have the any kind of candidate or person, please tell them about this project and send us comment to Araki-san or to the Google Home anytime.
What is the kind of process that you imagine for?
I think we have the Google Home to have the comment or to know the your interest. So I'd like to we would like to have the kind of that kind of information through Google Home, probably let's say by the end of next month or something like that. And in JAMSTEC side, we will review or read their suggestion or proposal. So we are going to decide how we can collaborate or who will be able to join the cruise or something like that. So first step is to fill out the Google form, probably within a month or so. Yes. So what about Cascadia side, Canadian side? Do you think you have any student or early career scientist?
Yeah,
or
these are not
science?
very long cruises, right? These are,
Mm.
it's not like 2 months.
Alexander, do you have the
cruise.
schedule, cruise plan?
It's easier to, yeah, that way. Yeah, we Martin knows better. Of course, he's leading the Northern Cascadia subduction zone observatory, including seafloor GNSS acoustic and what's it called, Martin and Earl, a frontal deformation or something, yeah, involving continuous monitoring with including boreholes and other things. And I guess it's not a big community in Canada. I presume some of the young scientists, seeing these are not very long cruises, may be willing to get some experience, at least not contribute in a major way, but to seek future opportunities to observe and learn, get some experience, and then we can think about what to bring back home to look at the Cascadia system. Tian, what do you think?
Yeah. So how large is the science party we are thinking about here? Like, and how many room are there for the very early career people, like graduate students? Like, I'm just curious about the availability for very young people to join this. Like, how large is the party? Like,
of course, we are trying to minimize the effort by the scientist itself to just build the observatory. So I think bedroom is plenty indeed. But Kodari-san, do you have any idea about the traveling fund or something like that?
Yeah, good point.
This is the point,
But
I think.
basically, and JAMSTEC, I mean, it's not easy for JAMSTEC to prepare the funding about participation of foreign scientists. So that is kind of a very pity point. But we would like to ask participants to prepare their own funding by themselves.
It's just travel, right? Fly
And yeah,
to Japan back.
yeah, something like that.
Anything on board is covered.
Yes.
Right, so it's not a lot, not a huge.
Mainly travel expense.
Yeah.
Okay. Thank you very much. And today we have the people from operations side, MARE3 group. Do you have anything you want to say? Engsan, sorry. Do you have any issue if foreign or non-Japanese scientists would like to join Chikyu cruise?
No, there's no problem.
No problem. In the logistic things, there is no problem.
No.
Okay. Yeah, I just wondering, usually, how do you call it? Helicopter escape training is necessary.
Well, that's needed, but that's the well, for this cruise, it may not require this since the scientists won't use chopper.
So maybe the scientist
May not,
does not.
but I need the double check. But
Yes,
there's a
please.
possibility of not necessary to have Hewitt for this cruise since all the scientists get on board at Shimizu and coming back to Shimizu. So
Okay. Okay, I understand. Thank you very much. Okay, so time is flying very quickly. It's already 10:30. So I think it's a very last part of discussion. If you have any additional confirmation question you want to ask. Okay, thank you very much. And thank you very much for very useful discussion about observatory cruise. I think so discussion here is very much helpful to make our project is successful. And also, Alex-san, thank you very much for presentation and answering many questions. Okay, we have the slide here. In the very bottom of the slide, if you have a question, kind of very specific question, you can ask anytime to Araki-san. And also, as I mentioned before, if you are interested in joining this project in any stage, please fill out the Google form indicated here, hopefully within a month. And we will read those suggestions and comment. And if somebody would like to propose or suggest to join the cruise, we will decide their participation after reading the proposal or suggestion. Yes, thank you very much. And if you don't have any additional one more things question, yes, or do you have a question?
Yes, I would love to see the slides that Araki presented. Is that possible or unreasonable to ask? Or
I think this slide is already distributed to audience. Am I correct?
Not all of the material is distributed.
So you can contact to Araki-san, and I think there is no problem to share his presentation with all participants in this symposium, if you want.
Thank you very much.
Okay. Okay, thank you very much. And one more thing, this symposium is, I mean, we recorded this symposium and will be open to community in the website. If you have any problem to do that, including your picture on the screen, please let us know. We will maybe we will not open some part of this recording if you don't want to do. Yes. Okay, I think we are going to close this symposium. Once again, thank you very much for your very thoughtful, important discussion. I hope to see you again, Chikyu cruise in Nankai. Thank you very much.
Thank you.
Thank you very much.
Thank you very much.
Thank you.
Thank you.
Bye.
Thank you.